Okay, right. So now we are dealing with question 5. In question 5, they say that give three values of k for which the x-intercepts of y 2x minus 1 squared plus k will be real, rational, and unequal. Right. So for this case, the way in which the roots for this whole given equation, for this whole given function, for them to have roots which are real, rational, and unequal, it's when the discriminant is greater than 0. Then if that discriminant is greater than 0, then your roots are going to be real, rational, and unequal. That is the only way in which the roots of the given equation can either have the roots which are real, rational, and unequal is when the discriminant is greater than 0, right? Now remember, in the maths curriculum, the discriminant formula is given as this b squared minus 4ac, right? Now we need to identify b, a, and c in this equation there and there. Now for us to be able to identify that, we're gonna need to expand that equation fully. We're gonna need to expand that whole entire function fully so we can identify which is our a, which is our b, and which is our c. So now, as of now, we are given that the function is 2x minus 1 squared plus k. If you expand that perfect square, you should get 4x squared minus 4x plus 1 plus k. Okay, then now what we're gonna need to do is to find our a, b, and c. Now to do that, let's just make this equation much easier for us to identify those factors or those variables. Let's just say 4x squared minus 4x plus k plus 1, and then put that in a bracket. So for us to find our a, so now we can easily identify that our a equals to 4, our b equals to minus 4, and then our c is equals to k plus 1. Right, so then now we can substitute all of those a, b, and c into this formula there of the discriminant. Right, and we can use, so we're gonna say that discriminant equals to our b is minus 4 squared minus 4, our a is 4, then k plus 1. If you do that, you're gonna get 16 minus 16k minus 16, and then you're gonna be left out with minus 16k. Right, so when you do that, you're gonna get minus 16k, right? So then your discriminant must be this thing there, must be minus 16k, must be greater than null. Now to get rid of the negative 16, we can see divide both sides by negative 16, dividing by negative 16. Now remember, according to intervals, if you divide by negative, the sign is going to change this way. So we are looking for values of k, which are less than 0 basically. So we are looking for all the values of k which are actually less than 0. Now, in the way that you can think of it now, we can try doing trial and error. Now they say give three values for which the x-intercepts We can try doing trial and error to see which of those values give us um, three values of k can it be, because now we have found that we need values which are less than k, but those values they must give us nature of roots which are real, rational, and equal. Then if you do trial and error like setting k, like if you say let k equals to minus 1. Let's see if you let k equals to minus 1. Let's see, um minus 16 times minus 1, you're gonna get you're gonna get 16. If you let k being equals to 16, if you let k equals to negative 1, you're gonna get 16. And then remember, if you do now remember those roots must be real, rational, and unequal. Now if you let k being equals to negative 16, negative 1, your nature of roots is gonna be basically be minus 16 minus 1, and you get an answer which is 16. And that is basically the answer what we're looking for, because if you do the square root of 16, you're gonna get square root 4. Now if we try to let k being equals to negative 2, let's see, you're gonna say minus 16 times negative 2, you get 32. And then if you do the square root of 32, you get an irrational number. So we basically not gonna need it, because immediately you do the square root of 32, you get an irrational number, and we're looking for rational. 16 is rational, so k is still valid. Let's try negative 3. So if you say minus 16 times negative 3, you get square root 4, you get 4 square root 3. That is still not valid. Let's try k being negative 4. If you say minus 16 minus 4, you get 8. So when you let k equals to minus 4, your discriminant is minus 16 minus 4. Your nature is given as minus 16 times minus 4, you're given as 64. So that could actually work as well. Now another one that we can try, we can go on, maybe let's try negative 16 times minus 5, you get 80. If you put that in the roots, it's going to actually give you any rational number, so that's not what we want. Let's try negative 16 times negative 6, we get 96. No, it doesn't work. Let's try negative 7, it won't work. Negative 8, it's not working out. Minus 16 times 9, yeah, 9. Because when you negative 16 times 9, it's 12. Yes. And then we can say let k equals to negative 9. Our discriminant, we get negative 16 times minus 9. You get minus 16 times minus 9, you get 1144, and that is a rational number. Yeah, and then you could have went on and on to try finding other ones, but so far these ones, they just wanted you to find three of them. So we have k being negative 1, k being equals to negative 4, or k being -9. Now the other ones that you could have tried, we could try maybe possibly -1/4. Ne? Let's just say you said -16 times -1/4. That also could have worked. Ne? So you could have also went into using fractions rather than numbers only. You could have also tried fractions and see if that could have also worked rather than using big numbers and on and on. But for this case, these numbers for now, our k being equals to -1, k being equals to -4, and k being equals to -9, for now it's gonna work. And then I think the other one that we just tried at now, it was k equals to -1/4. That also would have worked out. Okay, and then that's how you would have found those numbers. Basically, this kind of a method is a trial and error. All right.